Hi class, welcome to lecture 4.1. This is essentially chapter 8 in the book. I'm giving you some practice problems. Obviously, as you may recall, these practice problems are not for grade. They're just there for you if you want to get a little extra practice in. And if you really want a challenge, you can obviously do the rest. Now this lecture is on risk and rates of return. And we're going to talk about a few things like standalone risk, portfolio risk, obviously the CAPM and the security market line. And so a lot of this information will be very useful for you figuring out a lot of the problems that you will see in Chapter 9 and on the test guide. Uh, that, Once again, though, Lecture 4.2 will probably be a little bit more important than Lecture 4.1, but I will say Lecture 4.1 is far more important than, say, Lecture 3.1 was for the Exam 3. We're going to start by talking about two different types of investment risk, standalone risk and portfolio risk. Standalone risk is the risk an investor would face if he or she held only one asset, whereas portfolio risk obviously incorporates a portfolio. Now, keep in mind that risk is defined simply as the chance that some unfavorable event will occur. So the greater the chance that something bad is going to happen, the riskier the investment. So let's take a look at two different firms here, Firm X and Firm Y. As you can see here, Firm Y has a much higher chance that something really bad could happen, but also has a much higher chance that something good could happen as well. And so, for Firm X is much more concentrated in one little bandwidth. And so in some ways you could maybe say that Firm X is a little bit a safer bet because it doesn't have near as much volatility on the upside or the downside. Now, what could this be like? Well, let's think about some basic averages from risk and return perspectives. Okay, standard deviation is one of those measures that we statistically use to measure risk. And so here you're going to see that the stocks that are going to give you the higher average returns also come with the higher risk. So for example, the highest return you're going to see here is small company stocks. Small companies are a little bit riskier than large companies, so they have a higher standard deviation. Now, also, stocks are usually considered riskier than bonds. So what you're going to see here is that they're going to give you a higher return and higher standard deviation than all the bonds. Now, corporate bonds are usually riskier than government bonds, and then treasury bills are about one of the safest investments you can make. They're often used for money market accounts, and the 90-day T-bill is, for example, is often used to decide the risk-free rate, meaning that there's not really any risk involved in investing in the 90-day T-bill because the government is pretty safe, the U.S. federal government, and we'll put it this way: if for whatever reason the U.S. government ever did default, you'd have bigger issues to worry about probably than whether or not you'd collect your money on your T-bills. So let's look at a few hypothetical investment alternatives. My only major point I want you to see here is take a look at the T-bills and notice that it doesn't really matter what different states the economy is in. The T-bills are going to give you that 5.5% each time, whereas the other four different types of investment products are going to give you a wide variety. Some are going to be doing better in recessions, others are going to be doing better in booms. And so, you can see here that T-bills are about as safe as they come. Now, why is the T-bill return independent of the economy? And do T-bills promise a completely risk-free return? Well, to answer those two quick questions, the answers are pretty simple. For the most part, a T-bill is going to be independent of the economy. It's going to give you it's guaranteed. It's going to tell you what it is. I mean, there'd have to be some kind of Armageddon end of time scenario where you wouldn't get your T-bill money back. Some people though do base the risk-free rate not just off of 90-day T-bills, but off of the LIBOR rate, the London Interbank Offering Rate. It doesn't really matter though. For the most part, it is considered a risk-free investment. You do have some things to think about, inflation, and you do have to reinvest it when it matures, so there's some reinvestment rate risk. But for the most part, you don't have to worry about default. So I think it's a pretty fair assumption that the T-bill is going to give you a risk-free return. Now, if you go back a couple slides and you look at the other four alternative investments, there was high tech and collections. High tech moves with the economy, and it's going to have a very direct positive correlation, and that you kind of expect. This is often like kind of a little bit of a growth phase here, a growth stock, so to speak. Collections is really counter-cyclical, and it's going to do well when everybody else is doing poorly, and this is somewhat unusual. Regardless, if you want to count expected rate of return, you can sum up the probabilities for each one of those different states of the economy and multiply them by the expected return during those different states of economy, and you can get an average expected rate of return. So here's the summary of the expected returns for the 5 different alternative investments. Remember T-bills, you knew it was 5.5%. You can add that up, divide it by 5, you're still going to get 5.5%, right? High tech's going to come up in the highest, and that makes a little bit of sense. It's a very usually growth-oriented sector of the economy. The market, what average stock market is going to give you, something around 10.5%. U.S. rubber is a little bit below that. It's maybe more of a steadier product within the overall market. And then you see collections is going to have the lowest return there. But does that mean that high tech is going to be the best investment? Well, it depends. A lot of that depends on your risk tolerance and how you decide to consider risk. So how do we measure risk? We measure risk using standard deviation. There are a couple terms that you might hear for risk are variance. You could also see volatility. Eventually we'll use the term beta, but for right now let's stick with standard deviation. Standard deviation obviously is the square root of variance, and or variance is standard deviation squared, however you want to say that. And then we have the formula here, which tells you it's the sum of the squared differences, okay, between the actual returns and the average returns, and you got a probability sometimes put in there as well, or you might divide by like something like n minus 1, all depending on the exact situation. But that's a standard formula right there for standard deviation. So let's take a look at how you might use this. Well, if you did this with T-bills, you're not going to get any kind of standard deviation, which is going to tell you there is no risk, right? However, you plug these numbers in for high tech or for collections or for U.S. rubber or for the market, you're going to see that there's going to be a lot more risk. Now, interestingly, U.S. rubber has a lower return and a higher risk than the market, so I would never personally invest in it over the market. High tech has the highest risk, but it also has the highest return. Collections has a pretty high high risk for its low return. So this is all something to kind of consider here. But based off of this information, I would probably not look at collections unless I was really considering that we're going to be going into a bad market pretty soon. Here are the different standard deviations for T-bills and U.S. rubber and high tech. As you can see, there's really no wave for T-bills because it's steady, and there's a higher but maybe smaller width wave for U.S. rubber, and then the high tech is spread out all over the place, right? So what really is standard deviation measuring? It's really measuring what we call standalone risk. And the larger the standard deviation, the lower probability that those returns are going to match your expected returns. In other words, that wave's going to be wider, right? Just like we just saw with high tech. So let's go back and take a look at the different investments that we had, and now let's add in risk. And as I pointed out earlier, collections in U.S. rubber are going to seem somewhat out of place because they're going to have lower returns but higher risk, and so they're not going to be the most promising investments, at least from a dominance perspective. You could say that the other investments dominate collections in U.S. rubber because why would you ever choose a riskier stock for a lower return? Now, one important thing to look at is the coefficient of variation. It's a standardized measure dispersion about the expected value that shows the risk per unit of return. And we'll actually talk about a couple different ways that you can actually look at risk and return together. This is the coefficient of variation, has risk over return. There'll be some times where you can look at return over risk with things such as the Treynor ratio or the Sharpe ratio, which we'll get into later. But if you look at these two, you can see here that A and B may look like they have the same risk, but A is going to be a little bit riskier because of the larger probability of losses. In other words, you got the same amount of risk, but you're not getting the same amount of returns. By looking at each one of these alternative investments, their risk per unit of return, you can see that collections ranks the highest. And in this case, it's kind of like golf. It's you don't want to have the highest number. In fact, the best number is T-bills because there's no risk, right? So obviously you're going to have a zero in there, and that's going to make it very hard to get anything but a zero from a math perspective. But look at the market. Your best bet here, if you're looking at risk per unit of return, is going to be the market. So sometimes you can't beat the market, and this is obviously using just these examples one of those times. If you remember, high tech had a higher return, but in this case, if you consider its risk, it just has kind of a relatively average coefficient of variation. So this brings us to the ideas of risk tolerance or risk aversion. Risk aversion is actually opposite of risk tolerance. Risk aversion assumes that investors are averse or somehow dislike risk, and so you've got to give them some kind of a return to encourage them to bear that risk. Risk tolerance, which actually isn't up on the slide, is how well you tolerate risk. And it's important to note that there's differences here with financial risk aversion and risk tolerance versus regular risk aversion and risk tolerance. Think about it. I may not be the kind of person that goes out and goes skydiving. Okay, I find that extremely risky behavior. However, I might have no problem investing in hedge funds or some small cap stock companies and having the majority of my portfolio invested in stock. The same guy that likes to jump out of jets or ski behind them on oceans or do all kinds of crazy behavior may not know a whole lot about finance and finds the ideas of putting his money even in bonds scary. So there can be differences here, so make sure you understand that. But risk aversion just basically means that that you're averse to risk. The risk premium is just this idea that you've got to pay me more on top if you want me to bear some kind of risk. So whatever I'm going to get for T-bills because of the risk-free asset, I expect you to add a premium on top of that for something that's riskier than a T-bill in order to compensate me for bearing that risk. Now let's talk a second about portfolio construction. Okay. Assume a two-stock portfolio is created with $50,000 and it's going to be invested in both high-tech and collections. Now, a portfolio's expected return is the weighted average of the returns of the portfolio's component assets. What does that mean? Well, that means if you know what the expected returns are for each of them, then you can figure out what the weights are, and multiply the weights by those expected returns, add them together, and you've got the portfolio's expected return. So if you're going to be 25% in high tech and 75% in collections, then you would take 25% times high tech's expected return plus 75% times collections expected return, and that'll give you the portfolio's expected return. So expected return is pretty simple. It's a weighted average. Standard deviation, on the other hand, that's a little bit more tricky, and it's going to really require a new probability distribution. So let's take a look at both of those. Here's the weighted average. Okay, so in this case you have 50-50, high tech and collections. You add those together and you're going to get an expected return for the portfolio of 6.7%. Now there's another way that you can do that using the different recessions. The different states of the economy, like recessions, below average, average, above average, and boom. And that shows you that you can do it this way as well, but you get the exact same answer. Okay. What about standard deviation? Because that one's a little bit more complicated. So here's the math with standard deviation, and as you can see, in this case you got the sum of the you're actually taking the square root, really, of the sum of the probabilities times the square differences between the actual expected returns minus the average. And that's a whole lot of math, but basically that gives you 3.4%. We'll show you in your calculator kind of an easier way of doing this as well. Now, if you put that risk at 3.4% over the return of 6.7%, that's the coefficient of variation of 0.51. Now, one of the most important things that we just did, you might not have noticed, is when we built this portfolio, look at what happened to the standard deviation of the portfolio. It went all the way down to 3.4%. So that's going to be a lot lower than high tech or collections. Now, this is really important from a math understanding because you're going to average returns. Okay, so nothing, mysterious happened there. But look what happened to the risk. You really changed the risk. You're going to change this coefficient of variation or the risk adjusted return, however you want to, talk about it. You're really going to make a major change here. And the major change is that it's not really in return because that's just an average, but you definitely lowered the average risk. And the reason there is why. I mean, the big question there is why. And the reason is that there's what's called a negative correlation between those stocks. And that's very important to understand. A negative correlation means that, when one goes up, the other one goes down. And so, in a lot of ways, they're going to cancel out the overall variance of the portfolio. So let's take a moment to make a couple major comments about risk. Standard deviation equals around 35% for an average stock. Most stocks are positively, though not perfectly, correlated with the market. So if you think about this, that P is not a P. That's actually called rho, that weird Greek symbol after IE. That means rho, which stands for the correlation coefficient, is usually going to be somewhere between 0 and 1. And if it's 1, or 0.99, that means that stock pretty much goes in concert with the market. Those stocks that you're more interested in, though, sometimes are often lower in closer to 0 because these stocks provide more diversification opportunities. All in all, combining stocks generally lowers the portfolio, and up until like say 20 stocks or even up to maybe somewhere in the neighborhood of 50, somewhere between that 20 and 50, you've pretty much gotten all the diversification benefits you're going to get, meaning that you've lowered risk as much as you can simply by just adding more. In other words, take a look at this graph. You see here that you've got two stocks that are perfectly negatively correlated, meaning they've got a -1 correlation coefficient. They're going to really kind of cancel each other out, and this is really going to change the risk in this portfolio. Both stocks, W and M here, will give you a 15% return, but they come with quite a bit of variance, as you can see by that bell curve type distribution, whereas if you look at the portfolio, it's telling you it's going to be staying nice and steady at 15%, and that's pretty impressive. So you basically took away a whole lot of the risk by adding both of these stocks in the portfolio. Now, this wouldn't be true if they were perfectly positively correlated, meaning that both of them had a correlation coefficient of 1. They both run in the same direction. Then when you add them together, you're going to get the exact same risk. Okay, so then in this case you get really no benefit, no diversification benefit of adding both of them in the same portfolio. What about a partial correlation, say like a correlation coefficient of 0.35? Well, here, and this is maybe a little bit more likely than a perfectly negative or perfectly positive correlation, you'll see that you're going to get some cancellation out, and you are going to have a slightly more compact distribution. So here you're getting both 15% if you hold Y and W separately, but if you combine them, you still get the 15%, but it's a much more compact distribution with obviously less variance. So I'm not going to ask you to know too much of the math involved here, but I do want you to realize that with the more stocks you add, the lower risk you're going to have in the portfolio, assuming that these stocks are not perfectly correlated. And this can be with adding stocks that have the same expected return so that your expected return is not changing. Now, as I pointed out, eventually the diversification benefit of adding more stocks is going to go away. At somewhere in the neighborhood of 20 to 50 stocks. Here I've listed about 40 stocks. And so eventually your standard deviation for your portfolio is going to converge to somewhere around 20%. Illustrating this is pretty simple. If you look, you'll see that that light blue area of risk is always going to stay there, okay? And that's going to be true, and that's certain, and that risk is going to be called market risk, or sometimes systemic risk, or undiversifiable risk, meaning it's not going away. And then if you look at the darker blue at the top, that's going to be your security specific risk. So sometimes that's called security risk, or it's called unsystemic risk, or even diversifiable risk, because as you add more stocks on the x-axis, you'll see that eventually you get to the point where you can't do it anymore. But as you add it, it's going to make a dent in your risk, but a less of a dent with each stock you add. So the most diversification benefits you get are with those first stocks that you add, and then it kind of smooths out over time to where you are, somewhere, around maybe 20 for your standard deviation. And the reason for that is because you're not going to get, much safer than whatever the standard deviation for the market is. So, standalone risk has two components: market risk and diversifiable risk. Now, remember, I told you market risk could be also called uh, systematic risk. It could also be called undiversifiable risk. Security risk or diversifiable risk can also be called unsystematic risk. Now, that market risk is really just a portion of a security standalone risk that cannot be eliminated through diversification. And we know how to measure this, and there's a neat term called beta, which we're going to get to. And then not every, but almost every investment product, security out there, whatnot, it's going to have some diversifiable risk as well, and that can be eliminated through proper diversification. So what's important here is, from a math perspective, we can prove for example, that we can lower your coefficient of variation, which means you can go out there and tell some folks, hey, I can't guarantee you I can get you a higher return, but I can guarantee you that I can mathematically lower your risk for the same expected average return. And that's one of the things that a proper portfolio manager would do. And that's why, for example, if you look at the Smile Fund that we have here at UTC, one of the mandates is that they don't hold more than about 5% in a position. Maybe it could run up to 10%, but they can't buy in at less than 5%. At more than 5%. And the reason for that is because that pretty much mandates that they have to have around at least 20 stocks in that portfolio. So we're basically mandating that they have a decent amount of diversification. So if an investor chooses to hold only one stock in their portfolio, would that investor be compensated for the extra risk they bear? No. Okay, and that's really important to understand. In other words, you can read all these bullet points, but the main point is you're not really going to get compensated for holding unnecessary risk. Now, how do we mathematically go about figuring out what the expected return for a portfolio should be? Well, one of the unique concepts that we're going to use is called the CAPM, the Capital Asset Pricing Model. And really what this is going to do is link risk and return. If you look, R with a little I is going to be, my guess here is that little I stands for investment. It doesn't really matter, but it could also be for portfolio. But so if that first R stands for the expected return of investment, the next one, R with a subscript RF, is your risk-free rate of return, somewhere around 2%, 3%, 4%, something like that usually. It's based off a 90-day T-bill. It can be very low at times, and it can be a little bit higher at times. Right now it's really, really low, and because interest rates are so low in today's market. Then the RM stands for the return on the market, minus that risk-free rate again, and that's all going to be multiplied by a beta for that investment. And that beta is really based on the market risk for a particular investment and how it correlates with the overall market. So, for example, if you invest in stock ABC and that stock has a beta of 1.5, that means if the market goes up 1, then stock ABC is expected to go up 1.5, right? So if the market were to go up 1%, you'd expect it to go up 1.5%. And if it went down 1%, you'd expect it to go down 1.5%. So it tells you kind of how you'd expect it to move with relation to the market. In other words, this allows you to figure out kind of the relevant riskiness of a stock and its contribution to the riskiness of a well-diversified portfolio. So I would know how to do the CAPM. You're obviously going to need this at some point. I think I might have some problems for it for this exam, if not definitely for future exams. Now let's go back over beta again, since that is kind of a new term. Remember, beta measures stocks' market risk and shows a stock's volatility relative to the market. Again, let's pick a stock. Let's make up another one. Let's say WWF. Okay, so the stock WWF has a beta of 1.3. That means is if the market goes up 2%, then it's going to go up 2 times 1.3, so that would be 2.6%, right? And if it goes down by 1%, then it would go down, stock WWF would go down by 1.3%. So any stock with a value greater than 1, with a beta of greater than 1 is going to be riskier than market. Any stock with a beta that's less than 1 is going to be, have less risk than the market. Right now, like our small fund, for example, has a beta of 0.98 or something like that. So it is just barely, the whole portfolio is just barely less risky than the market. So let's go over some major concepts about beta. If the beta equals 1, the security is just as risky as the market. So the beta for the market equals 1. By the way, the beta for a risk-free asset is 0, okay, because there's no risk involved. But the beta for the market is 1. So if it's 1, the security is just as risky as an average stock or the market. If it's over 1, it's a little bit, that means it's riskier than average. If it's less than 1, it's less risky than average. And then almost all stocks, if you Google them, put their tickers in and look up at them, especially the big companies and whatnot, their betas are going to range from 0.5 to 1.5. So can the beta of a security be negative? Well, sure it can if the correlation between that stock and the market is negative. It's not really likely, but it could possibly happen, and there are some things out there that are set up to kind of purposely give you some kind of negative correlation. Insurance sometimes is set up like that. You don't expect to cash in on insurance because you want things to keep going well, but in case things turn bad, then that's what insurance is there for. You could also look at some ETFs, those are called exchange traded funds, and usually you can bet on different types of indices or indexes in the market where you can get something that's called a bull ETF, and that's expecting that that market to do well, or you could get something called a bear ETF, which is betting pretty much against the market. And so a bear ETF is going to have a negative correlation with the stock market, and so would like a lot of derivative products or something where you're shorting, okay, or going against the market. There's also some real assets, precious metals, real estate, some other things that might have lower but not necessarily negative correlations. So most stocks, though, are going to be positively correlated and be somewhere in that 0.5 to 1.5 beta range. Now, when you're calculating betas, what you're really wanting to know is not what they're doing now, but what they're going to do in the future. Unfortunately, none of us have a crystal ball, so we pretty much have to rely on historical data. So if you look at all the past data and you get a slope of that line is really going to help you define what your beta coefficient is for that security. For example, here if you look at these different points and you run a line, you're going to get a slope, and that slope, if you all remember what a linear equation looks like, is going to be that number that's going to be in front of Rm, and in this case it's going to be that 1.44 number. And then here you can see a couple different beta coefficients for high-tech, collections, and T-bills. Okay, obviously you're just looking at the different directions for the slopes, and that's a very good indication of how you would calculate your beta. So if we compare expected returns and beta coefficients, what you'll see here is that riskier securities in general have higher returns. So from this perspective, the order makes a lot more sense than it did when we were just looking at standard deviation. And notice collections even has a negative beta, which like we said is rare, but you can sometimes use that to your advantage. Now, when you're calculating the security market line or the CAPM, if you'll notice, one of the things on here is, you got that equation again at the very top, but underneath it, it says R equals, or R sub I equals R, sub RFs, meaning that the expected rate of return equals the risk-free rate plus, and what's that big RP subscript M? What is that? Well, that's called the risk premium for the market right there. So if you look what they're saying, we talked about a risk premium before, saying it's It's what you should get for bearing any kind of risk above the risk-free rate. And that's exactly what it is here. So if you take what the return on the market is and you subtract the risk-free rate, whatever that is, that's a risk premium. That's what you get for bearing the risk of, risky investments. And multiply that times beta, and so you can actually kind of simplify that equation somewhat, assuming that you know how to calculate a risk premium. And for example, they did that here where they used 10.5% for the turn of the market, 5.5% for the risk-free rate, and then you see that the risk premium is 5%. So once again, what is the market risk premium? It's the additional return over the risk-free rate needed to compensate investors for assuming an average amount of risk. Okay? You take more risk, you want to get paid for it. Its size is going to depend on the perceived risk of the stock market and investors' degree of risk aversion. And all that really means is that it can kind of range somewhat, and it's dependent a little bit on risk aversion as well. And it's going to range somewhere in the neighborhood of 4 to 8% per year. So now let's go back and use the CAPM security market line equations, and let's see if we can calculate our expected return for each one of these investment products. High tech, you notice that that's 5.5% after each equation. Remember, that's the risk-free rate and it doesn't change. And then you're going to see that 5% is not going to change either, and that's because the risk premium is also constant. The only thing changing here then is the beta. And so the reason all of these different stocks are going to have different returns is because they all have a wide range of betas, right? And so all the way from 1.32 for a beta down to negative 0.87. And that's why they have different expected rates of return. Now, once you've calculated each one of those expected rate of returns, you can look at it compared to what's known as the required rate of return. Okay, and so if required is what you require and expected is what you're going to get, then you can make some kind of decisions here. So if you take a look here with high tech, if I expect to get 12.4%, but I only require 12.1%, then I'm going to think that high tech is somewhat undervalued. The market looks like they're both equal, fairly valued. U.S. rubber, I expect to get 9.8%, but my required return for this amount of risk is 9.9, so that means this is overvalued. T-bills are always going to stay constant, and then collections, same thing as well. I'm expecting to get around 1%, but I kind of require a 1.15% return. So based on the amount of risk involved, so in this case I would say it's overvalued as well. Now what's interesting is all of these will be somewhere different on the security market line, and but they're all going to be pretty darn close to being on that line. And if you look, you'll see collections is down way at the far left, high tech is further up into the top right, and what everybody would love is, if you want that risk to be as low as possible, but the return to be as high as possible. So if you could be in the top left corner somehow, that would just be a great investment. That's pretty much a high return with no risk. But it's those don't come along too often. Let's take a look at an example. In particular, an equally weighted two-stock portfolio. So let's create a portfolio that's 50% high tech, 50% collections. The beta of this portfolio is going to be what? It's going to be exactly like the expected return. It's going to be a weighted average. So you take 50% of one beta, 50% of the other, add them together, and voila, bingo, you've got the beta of the portfolio. So really think about that. A beta of a portfolio is not very hard to calculate. Now to find the required return of a portfolio is the same way. It's an average. It's a weighted average again. So you take the weights, multiply them by each specific stock's return, you add them together, and voila, bingo, you got the return for the portfolio. Now you can also do this using the CAPM, which is pretty neat. These are supposed to equal each other, right? From a mathematically academic, perspective. If you want to find the return for the portfolio, you add the risk-free rate plus the risk premium of the market times the beta of the portfolio. So 5.5% plus 5% times the beta, which is 0.225, you're going to get 6.625%. Bingo. Now, where did that beta number come from? Remember, we figured that out in the last slide. So just go back to the last slide and you'll see where we got the beta of the portfolio. Now, we should also mention inflation. What would happen if investors raise inflation expectations by 3%? What's that going to do to the security market line? As you can see, it's just going to cause a 3% shift. All right. What about risk inversion? What if risk inversion increased, causing the market risk premium to increase by 3%? What would happen to the security market line? Well, now you're going to get an increase in the slope, right? Does everybody see that? And so, you've got some interesting things that you can, think about with the security market line. But one thing that's important to point out is that the CAPM has not been verified completely. There's still a few statistical issues that need to be worked out, and there's other folks that have some research out there that says there's some additional risk factors that should be considered besides just the market risk premium. But for the most part, it's a really good concept that gets us the majority of the way there. One of the big issues is that investors still, for some reason, seem to be concerned with both market risk and total risk. Therefore, maybe the security market line's not the best method for estimating, expected return. Finally, one last thought is that these concepts are going to be based upon expectations, but the betas are going to be used or calculated using historical data. And remember, although history often repeats itself, we can't say with 100% certainty that what happened in the past will happen in the future, and often it doesn't happen that way. So you got to take some of these calculations with a grain of salt with that respect. Nonetheless, this is a really good concept. It has a lot of practical implications, and I think it's one of those tools that you're definitely going to want to add to your toolbox, especially if you want to go into investments, become a wealth manager, portfolio manager, or a financial planner, or anybody that's going to be dealing with risk and return preferences for a client. Okay, so this is lecture 4.1, and if you have any questions, please let me know. Thank you.